Hey Calc kids, first things first, a couple of you guys have finished section 6.4 homework, which looks like this, or you guys have at least started on it, I know that for sure. But go ahead and try to get through that. If you have any questions, ask Keaton, because I worked with her, I don't know, the other day when you seniors were skipping out on school. So she knows kind of how to start each one of them, I guess. But what I want to do is I'm going to go through and start 6.5 notes, just because it's going to get crazy over the next couple days, and I know that track kids are going to be gone the next 2 days. So just to kind of get them a head start, I'm going to start and just do the front side of these 6.5 notes just so that you guys can, kind of get that part, and then the track kids won't be so far behind, I guess. So starting with 6.5, I put a couple of examples at the top here, and you don't necessarily have to write these down, but I put 4 examples at the top here, and each one of those is an antiderivative, or they call it integration, which is the process of finding an antiderivative. We said that, let's see, this is antideriv, and the process of taking the derivative is called differentiation. So those two things, integration means you're finding the antiderivative. Differentiation means you're finding the derivative, okay? So when you're finding the antiderivative, or when you're doing these integrals or integration, this would be just the straight rule, the 1 over n plus 1 x to the n plus 1. N plus 1 x to the n plus 1. That's the basic rule that you have for taking the antiderivative. This is technically a product, so I kind of want to go through like this would for derivative. For derivative, this would involve just doing the power rule, right? This would be a general power rule function. So for antiderivative, we just do the 1 over n plus 1 x to the n plus 1. That is kind of like the equivalent of the power rule for antiderivative, okay? This guy, for derivative, this would be a product, because it's the product rule, or two things multiplied together. But really, for antiderivative, we would end up multiplying those together. We would FOIL and then do 1 over n plus 1 x to the n plus 1, right? That would be the rule. That's what we would do. We would do that same thing. Okay, this would be a quotient, so we would use the quotient rule if we were taking the derivative. Quotient, I can't spell, I-E-N-T, quotient. But for the antiderivative, what we would do is we would move this x to the top and make it x to the negative 1 power, and then we would multiply the negative, or x to the negative 1 power through for both of those pieces. And so it's kind of like cheating around the quotient rule. And after we move that x to the top and multiply it through, we would still do the 1 over n plus 1 x to the n plus 1. So there's kind of a common theme going on here. Like antiderivative, you're always going to use this rule right here. Same thing with this one. This would be like a chain rule if we were taking the derivative of him. But taking the antiderivative, we would just FOIL that one again and do the 1 over n plus 1 x to the n plus 1, okay? So really, we have only learned basically one way of taking an antiderivative. It's just this rule. This rule, but preparing him for that takes a couple different steps. So, you might have to FOIL, you might have to bring the x to the top, you might have to rewrite him in some way before you can do that 1 over n plus 1 x to the n plus 1 power. Versus when you're taking the derivative, you have to learn each one of these individual formulas, right? So there's a little bit of a difference between antiderivative, derivative in that manner, okay? Now, we're going to learn the second way of doing an antiderivative. It's not it involves 1 over n plus 1 x to the n plus 1, but we have to do some preparation stuff beforehand. Okay, so this is called substitution, integration by substitution, and it's not like the substitution, elimination, substitution. It's not quite that easy, but you use this when you have composite functions, and a composite function is like a function stuck inside of something else. And let me kind of show you what I mean here. In example 1, we've got two pieces. We've got this chunk here, which is to the second power, and then we've got times 2x. So we've really got a product going on, but this left-hand chunk is a composite function because it's one function that's stuck inside of something else. So let me show you what the inside part is. X squared plus 1 is stuck inside of this square. It's basically like if I started with x squared, like this being my x squared, and I took x squared plus 1 and I shoved it in for this x. Okay, that's what the composite function looks like. Okay, and we'll get to more of that later on. But when you're dealing with a composite function or a function stuck inside of something else, okay, this one, the inside function would be 5x plus 1. It is shoved inside of the square root. So it's like I took the square root of x, but instead of x, I shoved in 5x plus 1 in his spot. Okay, so these are all composite functions, and there's something kind of special that happens with these composite functions. Okay. And let me kind of skip the box and let's just skip down to example 1 and you can see what I mean, okay? The composite function that I have going on here, this x squared plus 1, when we are using integration by substitution, we can only do this if the derivative, not the antiderivative, the derivative of this guy shows up another place in my integral. So if I'm looking at x squared plus 1, if I would take the derivative, not the antiderivative, the derivative, it would be 2x, and then the 1 would just cancel out. And my 2x shows up somewhere also inside of my integral, okay? So here's how we simplify this. We always will switch when you're doing substitution, we have to have something to substitute in. So they do kind of the same process every single time. They involve a u and a du. So you designate what u is and we designate what du is. And u is always going to be the composite function, or the function that is stuck function. I can't spell function. Function. Okay, the composite function of the function that's stuck inside of one of the other functions, okay? So in this case, my u is going to be the x squared plus 1, okay? And then du is just the derivative of this function. Like du would be the derivative of what u is, right? I take the derivative of u and I get du. The derivative of x squared plus 1 was 2x, and we noticed that it showed up inside of here, okay? So then, as soon as we have u and du, we go through this process and we just flip all of this stuff to terms of u and du, okay? And here's how this works. So I go through piece by piece. I start with my integral, okay? Start with my integral, and then I say x squared plus 1 squared. If I'm using these pieces over here, x squared plus 1, now we have named him u, so this will actually be switched to u squared. The x squared plus 1, we're taking him, crossing him out, and we're replacing him with u, and then this squared will just come down to be u squared, okay? Get rid of all my mess here, okay? 2x, wait. On the end of my du, I forgot. Du, the derivative of u is du, and x squared plus 1 is 2x, but I also need a dx on the end there. And what this does is it tells me that I have taken the derivative of this thing with respect to x, okay? So we need 2x dx. All right, so we'll fix that. You'll see that a little bit easier in the second problem when we do that. But du equals 2x dx. Okay, so 2x dx right here, I see him here, 2x dx. And what I'm going to do is I'm going to swap him out for du. So here I just have du. And then I have something that's a lot nicer to take the antiderivative of, okay? I am taking the antiderivative of this thing with respect to u. And all I do from there is I do the 1 over n plus 1 x to the n plus 1, okay? So u squared, if I do 1 over n plus 1, it would be 1 over 2 plus 1, because he's to the second power, u to the 2 plus 1 power, and then plus c. I need to make sure I have plus c because we're back to indefinite integrals. Okay, we don't have our limits of integration there. Okay, and then what this becomes, if I simplify some stuff, I have 1/3 u to the third power plus c. But And that would be my antiderivative, but now I go back through and I plug in what we renamed u to be, which was x squared plus 1. So I have 1/3 x squared plus 1 to the third power plus c. Okay, and this is going to be my final antiderivative. Okay, I know that was a little confusing. Let's go through another one, and the more we do this, the easier it will become. Okay, so the first thing that you always want to look for, we're going to do this one right here. The first thing that you always want to look for is what your u and du, you're going to name them as. Okay, so I'm going to say u is going to be the function that's stuck inside of something else. So that is 5x plus 1. 5x plus 1, and then du is the derivative of that thing, okay? That's one thing that's kind of hard about these problems is you're taking the derivative and you're taking the antiderivative all in the same problem, okay? So the derivative of 5x plus 1 is just going to be 5 because the 1 drops off, but it's 5 dx. That was the thing that I forgot to add up here to the top. So 5 dx, all right? So I've got my u and I've got my du and I have everything ready to go. So now I'm just going to start switching stuff. So the integral is just going to come down. I'm going to start by looking at this piece right here. So the square root of 5x plus 1, since we're naming 5x plus 1 u, this would be just the square root of u, okay? Now, 5, let me go a different color, 5 dx shows up here in my antiderivative. I have a 5 and I have a dx, so I'm going to replace that with a du. So even though that 5 and that dx is split apart with each other, it doesn't matter. 5 dx is going to be replaced with du. So this is going to be the thing that I'm going to be taking the antiderivative of, okay? So now I've substituted. Now I have to take my antiderivative. So I'm going to rewrite it over here. Integral square root of u du. And before I take the antiderivative of u, the square root of u, I'm going to call it u to the 1/2 power du. Okay? And then I just simply do the 1 over n plus 1, x to the n plus 1. So I have 1 over my exponent is 1/2. So 1/2 plus 1, u to the 1/2 plus 1 plus c. And then I'm going to go ahead and simplify some things. So 1/2 plus 1 as a fraction is 3 over 2. So this guy will be 3 over 2. So I have 1 divided by 3 over 2, which is just going to flip to the top as 2/3. You keep flip, flip, and it becomes 2/3. U to the 3 over 2 power plus c. And now my antiderivative is done. The only other thing that I need to do is I could switch this thing back to the square root. So this would be 2/3 the square root of u to the 3rd power plus c. And then the last thing that I need to do is plug in whatever u is. So I've got my u is 5x plus 1. 5x plus 1 to the 3rd power plus c. And that's my final antiderivative. Okay? All right. So that was only 2 problems. If you're still kind of snowed, it's okay. We got 2 more. All right. So 2 more problems here. We've got this information right here. Okay, and they already set up what my u is and what my du is. Now there's going to be one further step that's just a little bit more confusing here, okay? But we'll get through it. So we start with u and we start with du, and they say u is 2x minus 1. That's the part that's just inside of the other function. So 2x minus 1, that's what we're going to assign as u. If I take the derivative of all that stuff, the derivative of u is du. The derivative of 2x minus 1 is 2 dx. Okay, all right, so if we start simplifying some things here, I've got my integral symbol. I want to get rid of this square root, and so I have the square root of 2x minus 1, but we're naming 2x minus 1 u, so I switch it to u, and then dx is the only other thing that I needed simplified for. I've rewritten my integral, I've rewritten my square root of that thing, and I need to figure out what dx switches to, okay? Here, in this bottom problem right here, in this bottom line right here, I have that du is equal to 2 dx, but I want just dx by itself. I want to get rid of this 2. So here's the only other thing that you have to do that's kind of tricky. Dx, if I divide the 2 over to the other side, dx is like du divided by 2 or 1/2 du. I've kicked that 2 to the other side, right? 2 times dx would be the same thing as 1/2 du. Okay, So that's the only other thing is if there ends up being like a residual piece here, let me get rid of some of this stuff. If there ends up being a residual piece here that you don't actually need here, like sometimes there'll be a 2 out in front and then that whole thing will cancel out. But if there's not, and there's a 2 here or a number there that you need to get rid of, you just kick him to the other side and it will become 1/2 du or 1/3 du or 1/4 du, depending on what this number is to start with, okay? So that's how you get around doing that. So dx will be replaced with 1/2 du, okay? So du goes on the side here. And the 1/2, whenever I am left over with a number, I'm going to do this. I kick the number out to the very, very front and just kind of ignore it until after my integral is done, because a number that's out in front will not change what your antiderivative looks like until the very end, okay? So if you ever have that happen and you divide the number over, make it into a fraction like 1/2 du, and I'm going to split those two. I'm going to put the 1/2 out in front and the du in the back, okay? And then from there, I have it all switched. I've substituted. Check, that's done. Now I just need to find the antiderivative, okay? So u to the 1/2 power is how I'm going to rewrite him. And then I do the 1 over n plus 1 x to the n plus 1. The 1/2's just chilling on the front, okay? I'm going to put this in parentheses, what I end up getting. U to the 1/2 power. I think we did this one right up here. Yeah, we did u to the 1/2. Anyway, 1 over n plus 1, because n is 1/2, u to the 1/2 plus 1, okay? And again, that 1/2 plus 1 ends up being 3 over 2. So I have, I'm getting into the wrong spot here. Let's go over here. Okay, I've got 1/2 chilling. 1 divided by 3 over 2 is 2 over 3. U to the 3 over 2 power. Okay, and that's what he simplifies to be. And then the only other thing I can do is just multiply those two guys together. So 1/2 and 2/3, those 2's can cross out. So this just becomes 1/3 u to the 3 over 2 power. I'm going to rewrite him as the square root of u cubed, because that's what the 3 over 2 power does. Kind of like what we had up above. I need to have a plus c. And then last, I need to switch that u back to x's. So I had whatever u was standing in place for, which was 2x minus 1. So 2x minus 1 plus c. And that's what he is. Okay? All right, one more and then I'll let you go. Okay? So this one, u and du. Your u is going to be whatever's stuck inside of something else. So I have x squared minus 1. That's going to be minus 1, not plus 1, minus 1. That's going to be my u, and my du is the derivative of that. Okay, so the derivative of x squared minus 1 is 2x dx. Okay, so I've identified those two things, and now I'm going to start substituting. So I need my integral symbol. So I'm going to rewrite him over here. Okay, I'm going to start with this chunk inside of here, the square root. So I have the square root of x squared minus 1 is being replaced with u. That's what I've called him over here. Okay, and then the only other things, so he's done. The only other things that I have to replace are x and dx. Okay, x and dx, I see those right here, but I need to get rid of this 2 because I don't have 2x dx, I have just x dx. So I want to kick that 2 to the other side. So I divide by 2, and instead of writing as du divided by 2, I write it as 1/2 du equals x dx. Okay, so I can see that x dx, this x and dx, is going to be replaced with 1/2 du. So I cancel those guys off, and I'm going to do 1/2 du. I'm going to stick that 1/2 out in front and the du on the back, and the 1/2 is just going to chill. So I have 1/2 integral u to the 1/2 power du. And we've just done this all over again. We just did the same thing again, right? Oh my gosh. Okay, so I'm going to cheat until we get to this point. We just did that all that work. This is like the 3rd time we've done this. The antiderivative comes out to be 1/3 square root of u to the 3rd power plus c. But then I just need to fix him. The u is actually whatever we replaced it with, x squared minus 1 to the 3rd power plus c. Okay, so it's kind of confusing, and I know, I get it, but the more you do it, the better it becomes. we're going to wait to do the back side of this till the next time we're all together. Maybe that's tomorrow. I don't know. We'll see how many people are in class tomorrow, I guess. But we'll wait to do this. These are going to be definite integrals where you actually have numbers to plug in. I've given you your homework assignment. This top 1 through 4 is just identifying what U and DU are for each one of these problems, okay? And you're plugging those in. You're filling out this table right here, okay? You're not actually evaluating and doing the whole thing through. But 5, 6, 7, 8, 9, 10, go ahead and attempt those, and then just worry about those for tomorrow, okay? Try to get through those with the remaining time, and if there's any problems that you have left to do on the 6-4 homework, try to get through those as well, all right?